Hi everyone, we are still in the introductory topics towards preparing for Calculus 1. In this section we will discuss conjugates and rationalization. An irrational expression involving a square root, whether it be a numerator or a denominator, can always be rationalized, meaning that it can be converted into a rational number. For example, the denominator of the expression 1 over square root of a is or can be rationalized by multiplying the numerator and the denominator by the square root of a. This is something you've probably done in high school quite a bit. Again, multiplying by root of a above and below guarantees that we're not altering the value of the fraction. However, by doing this multiplication, the denominator, root of a times root of a, becomes a, which is meant to be a rational number. At the top, obviously, now a root will appear. Expressions of the form a plus or minus root of b, or root of a plus or minus b, or even a sum or a difference of two rooted numbers can also be rationalized by multiplying them by their conjugates. Here's the list that shows the pairs of irrational expressions that are mutual conjugates of one another. A plus root of b has, as its conjugate, a minus root of b. Root of a plus b has as its conjugate, root of a minus b. And the sum of root of a and root of b has as their conjugate the difference of the root of a and the root of b. Of course, it's always mutual, hence the double-sided arrows. So these are always conjugates of one another that we've paired up. You'll notice that multiplying conjugates generates a difference of squares, which is why irrational terms will be eliminated. For instance, if you multiply a plus root of b with a minus root of b, then expanding this product will actually show that minus a root of b and plus a root of b become canceling terms. And the outcome will reduce to a squared minus b. Now, assuming a and b started off as rationals, now a squared minus b is definitely a rational result. Here's an example. Let's rationalize the denominator of the fraction 8 over root of 7 minus root of 3. I'm going to simplify the result if it's possible. Now recall that if you have root of 7 minus root of 3, then root of 7 plus root of 3 will be its conjugate. In order not to alter the value of the fraction, we're going to multiply by root 7 plus root 3 above and below. At the top, we've regrouped the numerators together, and same at the bottom. Now don't waste any time expanding or distributing 8 to the sum of root 7 plus root of 3, because there would be no advantage to do so. However, at the bottom, root 7 minus root 3, root 7 plus root 3 is clearly a difference of squares that will reduce. Actually, it's the pair of conjugates that we're trying to combine to create a rational number. When you do this expansion, you will find that 4 is the result of the denominator. And now 8 over 4 can be even reduced to 2. Notice how the outcome no longer has an irrational denominator. However, it has an irrational numerator. In this next example, we're going to rationalize the numerator of the fraction x plus root of 2x plus 3 over x squared minus 1. And we're going to try to simplify the result, assuming that x is not minus 1. We'll see why this restriction is imposed later on. The conjugate of the numerator will require that we change the sign that appears between x and the root of 2x plus 3. We're going to multiply the rational expression or the fraction that we started off with above and below to maintain the value that we currently have. by x minus root of 2x plus 3. There we go. So we're multiplying above and below by the same conjugate that is meant to rationalize the numerator. Now, rules of fractions allow us to combine numerators together or to multiply numerators together and denominators together. Really, you don't want to waste your time, once again, expanding the denominator. There is no gain from expanding the combination of x squared minus 1 with x minus the root of 2x plus 3. These are not conjugates of one another. So we're going to leave them side by side. As for the numerator, again, we have a difference of squares generated by the conjugates, and therefore x squared minus the root of 2x plus 3 squared will be the outcome of the expansion at the numerator. So we've created a difference of squares, which obviously reduces to the rational expression x squared minus 2x minus 3. At the bottom, we still have our two factors side by side. No manipulations have been done so far. Here's where we're going to see if we can simplify things a little bit. So the numerator is a quadratic, which turns out to be factorable by using the sum product method. At the denominator, x squared minus 1 is a difference of squares, which factors into x plus 1, x minus 1. You'll probably recognize that x plus 1 is a common factor of both numerator and denominator, and a simplification can be done by eliminating these common factors. The end result no longer presents roots at the numerator. However, since we have eliminated the x plus 1 factors, we should take note of the fact that x is restricted and cannot be minus 1, since the original of these two expressions was undefined at minus 1.